having seen the SI system of units and the prefixes, let us take up the formal definition for the physical quantities concerning circuit theory. First of all, let us take the definition for voltage. The voltage across any terminal pair is a measure of the work required to move the charge through the element. Right? This is a formal definition for voltage. We will see the associated requirements later. Next, let us take a power. Power is a rate at which energy is expanded. This is a expended. That is a general definition. Capital P or lowercase p, it will be denoted by. It is nothing but the product of voltage and current. Voltage is nothing but the energy required to move the charge, joule per coulomb, joule per unit charge. I is the rate of change of charge, C by T. Cancelling C and C, we get joule per time. This is nothing but watt, the unit. Now, let us take up an important convention called passive sign convention. This is very, very important because worldwide circuit theory is being taught and understood. This necessitates a convention for the definition of power. This convention states if the current enters a circuit element through the terminal marked positive, then power absorbed by that element, power expended by that element can be expressed by the product of the specified voltage and current variables. Right? If the current enters the element through positive terminal, then power is being absorbed by the element. Mind you, keep it in your mind. Current enters through the positive terminal, then that element absorbs energy. Suppose if it enters through the negative terminal, it generates, or rather that element delivers power. Right? Having seen this important convention, let us move on to define the rest of the quantities. Current is nothing but rate of change of charge. Its unit is ampere. Charge is nothing but integral dq between two limits, time limits. Q of t naught to Q of t. It is nothing but t naught to t I dt prime. dq from this. dq is nothing but I dt. Ignore that prime. Now, let us see the different types of currents which are possible. Constant current, that is DC, direct current. With time, it is constant, a flat, straight line parallel to the time axis, that is x-axis. Now, sinusoidal, that is AC current, alternating current. This is what time versus I will look like this. Now, exponential, I versus t, exponentially varying. Mind you, this is an asymptotic variation and the current will approach the zero value at infinite time. Damped sinusoidal, this is a special case. Sinusoidal, at the same time it is getting damped. Right? Now, let us see certain points regarding voltage. The definition of voltage should include plus minus sign pair. If it is marked without plus minus sign pair, it is an undefined term or quantity. Mind you, always voltage should be marked with plus minus sign pair. Regarding passive sign convention, current enters through the terminal marked positive, power is being absorbed. absorbing or expanding, P equal to Vi. If power is negative, that power is being delivered, or that element is delivering, generating that much power. So, if you change the sign, absorbed power will become delivered power. Delivered power will become absorbed power. Right? Huh? We'll see an example. An element is here. A current I enters through the terminal marked positive, and a voltage V is sitting between these two terminal pair. Let us say, example, 5 volts V. I is minus 4 amperes. Then the absorbing power is simply the product of these two quantities, minus 20 watts. Alternatively, generating power is plus 20 watts. Clear? So if you change the sign of the quantity of the power, the value of the power, you will get either value. Generating, if you change the sign, will become delivering. Delivering, if you change the sign, will become generating. Right? Now, let us take up some simple problems regarding power. For example, this is the first problem. Compute the power absorbed by each element. You may wonder why elements are marked as a random figure. Because we have not taken up the formal definition or the formal picture of symbol of the various elements, say voltage sources, current sources, resistances, and etc. Now, the first element is taking up a current of 3 amperes through the terminal marked positive, and a voltage of 2 volts is sitting across these two terminal pair. Now see, power is nothing but simply the product, because passive sign convention dictates if the current enters through the terminal marked positive, power absorbed is nothing but a simple product. What we are asked to calculate? Absorbed power only by each and every element of these 3 elements, right? Simple product is 6 watts. Here also simple product, minus 2 volts is sitting across this terminal pair, and minus 3 amperes is entering the terminal marked positive. Again, see, mind you, positive here, negative here. Don't mistake, take it as negative terminal, right? Be careful. The drawing is saying that the top terminal is negative, the bottom terminal is marked positive. So again, simple product, 6 watts. Here, again, minus 5 amperes is entering through the terminal marked positive, and a voltage of 4 volts is sitting between the terminals. Then simple product, minus 20 watts is the absorbed power. Now, this is a B. Here also 3 elements are given, and the first circuit states that a 220 millivolts is sitting across this terminal pair, and a current 4.6 amperes is entering through the terminal marked positive. So power absorbed by this element is nothing but 220 millivolts, 0.220 volts into 4.6 amperes, which will give you 1.012 watts as the power absorbed by this element. And here the current minus 1.75 amperes is entering through the terminal marked negative. So minus 3.8 volts is sitting across. So after taking the product, we have to change the sign to find out the absorbed power. See, power being generated by the element in B. Which will give you minus 6.65 watts, the simple product. No, the simple product minus into minus will give you positive plus 6.65 watts. But we are asked to find out the absorbed power. Here current enters through the negative terminal. Simple product will not give you the absorbed power. It will give you the generated power generated by this element. So absorbed power, you have to change the sign. So it is minus 6.65 watts because the product will give you positive value 6.65. Now third one, power being delivered to the circuit at, see, mind you, see the English wording, absorbed by the element. Power absorbed by element is nothing but the power delivered to it, or putting in other words, the power expanded by that element. So again, upon seeing delivered, don't jump to conclusion that we are asked to find out the generated power. No, it is the power absorbed by that element. That power is being delivered to that element, right? At t equal to 5 milliseconds. Why this is needed? See here, the voltage sitting across this element is 8 e power minus 100 t, exponential function, this many volts. And the current entering through the negative terminal is 3.2 amperes. So simple product let us take, which will amount to minus 15.53 watt, the simple product. I have not worked out, I give it as an exercise to you. T equal to, what is that? 5 milliseconds. 5 into 10 power minus 3 you have to insert in this value of, in this function of voltage, right? So simple product will lead to minus 15.53. So power being delivered is, change the sign, because current is entering to the negative terminal. So the generated power, we are asked to find out the power delivered to that element, which is nothing but 15.53 watts.